Hey everyone, welcome back to another video. Um, this one's probably gonna be kind of short because I earlier I was working on my website, and I was able to finish it and deploy it, and that took a while. So I just wasn't recording it because I, sorry, I wasn't in a setting where I would be able to record it. Um, so yeah, I'm gonna try to do like one problem and then sleep because I'm quite tired. Which one were we on? No, so we did this one. Okay, we're on this one. It's a little hot. I'm gonna open that door. Um, Give the head of the linked list. Remove the end node from the end of the list and return its head. Hmm. Maybe we could count the length of the whole thing and then subtract n from the length and then stop at that node. So the first one, the length is 5. We want the second to last, so 5 minus 2. So we remove after the third node, which would be 1, 2, 3, 5. First off, if not head, then we return head, return none. Equals head, while cur, let's see, length plus equals 1, cur equals cur dot next. Stop equals length minus n. Um, while length is less than stop cur equals, oh, we set cur equal to head while length is less than stop cur equals cur dot next. So say n was 3, there we go. So we go 1, 2, wait, so we go 1, 2, 3. No, so we want to stop 1 early. And then cur next equals cur stop next. Then we return head. Fuck, I knew it. Oh. How many of these am I getting? 180. Okay. What's wrong here? One minus one would be 0, so length equals 0. While length is less than stop, -1. So stop would be 0. -1 would be -1. So length would never be less than that. Or it would always be, so it wouldn't even run. And then cur, if cur.next, then nope. Well, that one is null. Huh. If stop is, so maybe some edge cases. So if stop is because in this case, like this one, so it'd be 0. Okay, nice. Should be open, right? Because we just iterate through that. Iterate again. Should be open. Yeah, so the edge case with the head, where if it's the head, then you just increment the head by one because you can't get access to the node before it. Or maybe you could with a dummy node, but um, maybe that's the solution. I'm gonna watch NeetCodes real quick.
Hey everyone, welcome back, and let's write some more NeetCode today. Today let's solve remove nth node from the end of a list. So we're given a linked list, and all we need to do is remove the nth node from the end of the list and then return the new list. So that's pretty straightforward, right? So in this case, we got 5 nodes. We just want to remove the n equals 2, so meaning the second node from the end of the list, right? So this is the first from the end of the list, this is the second. So we remove this, and then we return this list, which now has 4 elements remaining. So what's the easiest way to solve this? Well, they say from the end of the list. That's inconvenient. If it was from the beginning of the list, it'd be super straightforward, right? N equals 2, remove this node. How can we make that even easier? I mean, what if these pointers were reversed? Can't we just reverse this linked list, start from here, and then remove the second node? And then we're done? That's definitely a possible solution, but it requires reversing the linked list, which we don't actually have to do. And I'm going to show you the easier way to do it. So let's say n equals 2 again. So we want to remove this node. So how can we identify that this is the second node from the end of the list? Like a lot of linked list questions, we can use 2 pointers, but how are we going to make use of our 2 pointers? So what if I had 2 pointers, right? A left pointer and a right pointer. The left pointer is at the beginning of the list, and the right pointer is shifted by n equals 2. So our right pointer is going to be shifted 1, and then it's going to be shifted again, and our right pointer is going to be over here. So now we're just going to keep shifting our pointers until this right pointer is at the end of the list, and watch what happens when we do that. So we're just going to be shifting each pointer by 1. And this is going to make sure that the space between these pointers is exactly equal to n, which is 2, right? So now we're going to shift by 1 again, making sure that the gap between them is still 2. Now we're going to shift 1 last time because right is almost at the end. So now our right pointer is at null, right? It's at the end of the list. It can't go any farther. And our left pointer is exactly at the node that we want to delete. And the reason is because, remember, the offset between these two is n, making sure that we have the node we want to delete. Now, there's only one problem. We have access to the node that we want to delete, but we want to delete it. How do we delete it? The only thing we have to do is take this pointer, cross it out, and then reassign it over here, right? Once we've done that, we've gotten rid of this node. So the problem is we're at this node when really we want to be at this node if we want to delete this node. And this can actually be solved by another pretty common technique, the dummy node, right? So we're going to actually have another node that we insert at the beginning of this list that we don't really use. And the main thing that's going to happen is instead of our left pointer being initialized here, we're actually going to initialize it at the dummy node. So left is really going to be initialized here, and our right pointer, though, is still going to be initialized over here. So in reality, when our right pointer reaches the end of the list, we will have a left pointer at 3, and then we can update its pointer, removing this node that we want to remove. And to return the new linked list, all we have to do is take our dummy pointer and say return dummy.next, which is going to be this node. And since this is a 2-pointer technique, the time complexity is going to be big O of n. So just like in the drawing, the first thing we really want to do is create a dummy node. We don't really care what the value of this node is, but I'll just say 0. But we want to make sure that the next pointer of this node is set to the head of the list because we're inserting it at the beginning. Next, we can initialize our left pointer to dummy, and we want our right pointer to be head plus 2, right? Or head plus n, whatever n happens to be. So we need a loop to do that, right? We can't just do that with a calculation. So we can initially say right is equal to head, and while n is greater than 0 and right is not null, we want to keep shifting right. So shift right by 1 and decrement n by 1. Because once n equals 0, that means we've shifted by the amount that we wanted to shift by. And the last thing we want to do is keep shifting both of our pointers now. Now we're shifting left and right, and we're going to keep going until right reaches the end of the list. So we can shift our left, right, head with a calculation. While n is greater than 0 and right is not null, we want to keep shifting right. So shift right by 1 and decrement n by 1. Because once n equals 0, that means we've shifted by the amount that we wanted to shift by. And the last thing we want to do is keep shifting both of our pointers now. Now we're shifting left and right, and we're going to keep going until right reaches the end of the list. So we can shift our left pointer, and we can shift. We want to update the shift dot. My left pointer doing is our list, which is what we want.
do need a... I'm just gonna go ahead and do his. Oh. No.
Want to return, we want to return the updated list, so we can just return dummy.next. We don't want to include our dummy node in the output.
In a way that works. Why can't I return head? Should work. Because theoretically, it would never be. Oh, no. It's not like head incremented, did it? Oh, if the head was removed, yeah. Okay. I think I'm gonna sleep now. It's already 4 o'clock, but I'll try to hit the ground running tomorrow. I really need to be better about this stuff. I'll see y'all though. I'm sorry for this short ass video, but hope y'all are doing well. And yeah, I really need to be more locked in and be more proactive with when I start and stuff. See ya.